Scientific notation. The universe is 210, and I don't even know how to pronounce the next part of it, but it is a 21 with 22 zeros after it. This is a really large number, so we're going to look to see how scientific notation can help us write these numbers in an easier format. Scientific notation, then, is a way to write really, really big numbers or very, very small numbers. It's expressed in the form of a times 10 to the nth. And a needs to be between 1 and 10, but does not include 10. And n is an integer. We're asked to write the width of the universe in scientific notation. And I have that extremely long number of the width of the universe. Remember that there's 22 zeros in this. So the decimal point right now is at the very end of our number. And what we need to look to do is put this into the form of a times 10 to the nth power. And a needs to be between 1 and 10, but not including 10. So we need to move this decimal point all the way to the front, and we're going to put it between the 2 and the 1. So I would have 2.1, 0, 0, 0, 0, 0, but we don't need to write all of those zeros out. But now we're looking at what power of 10 is this raised to? Well, remember there were 22 zeros. But if you think about moving that decimal point to each of those, we would count over 22 for all the zeros, and one more, 23, for that next place. So in scientific notation, the size of the universe is 2.1 times 10 to the 23rd. Sometimes we are asked to take something in scientific notation and change it to standard notation. Here we are given 7 times 10 to the negative 6th is the size of the nucleus of a human cell. Let's first take a look at what negative exponents mean. If I was given the number 0 and 3/100ths, you can think about this as 3 cents, how would I write this in scientific notation? Well, I would look and see that this is actually looking at a negative exponent. I need to take my decimal point and move it backwards, so this would be 3.0 times 10 to the negative 2nd power. Remember, negative exponents need to take the reciprocal, so this is 3 times 1 over 10 squared, or 3 divided by 10 squared, or 100. And we can see that 3 over 100 is indeed 0.03, or 3/100ths. With that in mind, then, we know that we're going to be looking at a very small number. So 7 times 10 to the negative 6th, I'm going to start by saying that's 7.0. And I need to move this decimal point then so that I create a very small number, where I'll be moving it to the left 6 places. 1, 2, 3, 4, 5, 6 places. This now gives me the standard notation of 0.1234, and then a 7. So 0.7, and if we think 6 places out would be to the tenths, hundredths, thousandths, 10,000ths, 100,000ths, million place, or 7 millionths is our answer.